Hi everyone, my name is Robbe. I'll be presenting our work called Blending Spaces, Cross-Reality Interaction Techniques for Object Transitions Between Distinct Virtual and Augmented Realities, which is the work of Augusto, Esteves, Adalberto, Simeone, and myself. So this work deals with cross-reality interaction, and in contrary to traditional interaction techniques, which focus on a single point of the reality-virtuality continuum, we focus on interactions that happen across this continuum. So one of these problems is how to visualize and interact with an environment from a different reality. So how can, for example, an external user or an augmented reality user interact and visualize a completely virtual environment? For example, if you want an external user to involve them in a VR application, you need to add displays on the outside of that one display, or involve them in some kind of projection system, or give them a handheld display. Collaboration between AR and VR users is somewhat different because they can both see 3D objects, so they could co-manipulate an object, for example, or we could investigate how to visualize a VR user in a virtual environment to an augmented reality user. So in this AR-VR case, we investigated how we could filter a virtual environment to show it to an augmented reality user. And we did this by just selecting objects to show to the AR user. And in this case, we say that the environments are equivalent because all objects from the augmented environment are in the virtual environment. Now, not always will these environments be equivalent, so they can also be distinct. So this is useful if, for example, a video game modeler is making some asset and they are using AR because they reference real-world materials, but then they want to transition it to a virtual environment, which is a different environment that represents the game, for example, to see it in context. Or as the example in our study goes, an augmented reality museum curator who is making an AR exhibition, and they want to reference a replica of a archaeological site with artifacts and transition them between the two environments as part of their task. So what new problems does these two distinct environments raise? And we envisioned the most important one is how to transition objects between them. So for this, we investigated literature. For example, there's a reach into approach, which are lenses, basically. So a lens allows the user to move around the viewpoint, which can show something different. So a different version of the same environment, as is this the case with the wireframe, or a different environment altogether that they can reach into and manipulate object and take the objects inside and in and out of the lens. So this is one approach. And then another approach is to not allow them to access it from one environment, but to transition them completely to the other environment. So that would be a step into approach, where the user moves completely from the augmented to the virtual environment. And the Magic Book is an example of this, because the user can transition between an AR view of the scene to a VR view of the scene. Seamless bidirectional transitions between VR and the real world have also been investigated. And similarly, there's also papers that focus on transitions between virtual environments. So they investigate the multiple methods of moving VR users between different virtual environments. And as such, this step into approach is a possibility to have the AR user access the virtual environment. So both these approaches have some downsides. So the reach into approach only allows the AR user to see a limited view of the virtual environment, and the step into approach causes them to transition completely, and thus they lose their awareness of the augmented environment, which may also not be wanted. And because of this, we chose to investigate a third approach, which is blending. So as an inspiration for this blending approach, we looked at smooth immersion, for example. So this is a paper where a user transitions gradually from the real to the virtual environment. So it introduces more and more virtual elements, thereby blending the two environments to transition the user. And then there's also the recent paper called Overlap, which investigates a user being at multiple points in the virtual environment by overlaying these different points using a see-through overlay. So now to design our VR-AR blended space, we investigated how we could do this, and we chose to take the AR user's perspective. So the blended space would be in AR, and then we chose to select a number of objects from the virtual environment, which would then be brought into the AR space to make a combined space. And so in this combined blended space, the user can see both the content from the virtual as from the augmented environment. And in order to make it so that they can still distinguish between the environments, we implemented the color coding where the blue represents the virtual environment and the yellow represents the augmented environment. We evaluated this blended space approach as an object transition technique. So we first have the two baseline approaches, which are the binary transition, a step into approach, the virtual magic lens, and reach into approach, and then two versions of blended space, so the manual blended space and the automatic blended space. The binary transition works by allowing the user to transition themselves alongside with the object to the other environment. The virtual magic lens allows the user to see the virtual environment in the lens and reach into it to take out objects. The manual blended space with button transition allows the user to see both environments at once and then press buttons above the objects to transition the objects to the other environment individually. And then the automatic blended space is also a blended space, but it assumes that when an object is picked up, it is also wished to be transitioned, and thus it initiates a transition when the object is picked up. We then evaluated these techniques in a study. So participants filled in a demographics questionnaire inquiring about age, gender, and mixed reality experience, and then performed a object manipulation task where they transitioned 3 objects from the augmented to the virtual environment and 3 other objects from the virtual to the augmented environment. And during this, we measured the task completion time. And then afterwards, participants filled in the NASA TLX questionnaire, which has these 6 scales. And then they repeated this 4 times, once for each of the techniques. And then finally, they ranked the techniques based on preference, and we interviewed them on why they preferred certain techniques and what they found made the techniques efficient. We had 20 participants, aged between 21 and 58, and they had medium mixed reality experience. In the study, we found that the auto-blended space was significantly faster than the baseline techniques, and also that it had a significantly lower workload than both manual blended space and virtual magic lens. The auto-blended space was preferred by most participants because they found it the easiest to use. Virtual magic lens was also very intuitive, experienced as intuitive, but participants found it annoying that they had to stretch out their arm to use it, and it also had a limited view, which they complained about. The binary transition caused participants to lose track of their original environment after transitioning, and then the manual blended space was poorly received specifically because of the button transition, where participants complained that it was very repetitive to use. So based on these results, we did a second study where we evaluated the technique on a more generalizable task. So we designed two new environments to do this. And then we also modified the manual blended space based on the feedback we received from participants, choosing to have a touch transition rather than a button transition. So this touch transition works by allowing the user to use their non-dominant hand to touch the object and to initiate the transition in the manual blended space. So we evaluated these 4 same techniques as in the first study, except with the touch transition replacing the button transition, in a study with largely the same procedure, except that participants performed a different task. So in this task, they had to stamp pieces of paper. So there's stamps with 1, 2, 3 and papers with ABC, and they had to move the stamp to the correct paper to place the correct number on the paper. They had to do this 3 times, once in the virtual environment, transitioning the stamp to the virtual environment, and twice in the augmented environment, transitioning the paper to the augmented environment. And because of the nature of the action, participants have to perform both a transitioning the paper, and then perform an intra-reality manipulation, like picking up the stamp without transitioning it. And with this task, we hoped to have a more generalizable task. So then we had 16 participants who were aged between 21 and 38 and who had medium mixed reality experience. In this study, we didn't find any significant difference in task completion time, though you can note that the auto-blended space performed notably worse compared to the first study. The NASA TLX resulted in a higher perceived workload for the auto-blended space compared to the binary transition. And in this study, participants preferred the manual blended space because they felt it very easy to see both environments at the same time while still having good control over the transition. The feedback on the virtual magic lens and binary transition was the same as in the first study, whereas for the auto-blended space this time around, participants found it very easy to make mistakes with, which is why they preferred it the least. Based on these results, we defined some guidelines. So the binary transition is mainly useful when you want to have a participant be in a single environment, and the goal would be to perceive the environment separately. So if you want to have the participant be very immersed in one of the environments, then it would be good to just transition them there. The virtual magic lens is good more for occasional transitions because it only gives a limited view of the virtual environment, and as such, it's more useful when one of the environments has a priority over the other, and the view of the virtual environment is not that important. And then finally, there's the blended space, which we showed was suitable for frequent transitions, but the exact transition mechanism is a very important design factor, as we found different results in both the studies. And then to end this presentation, I'll give an overview of the design factors of blended spaces. So there is the transition method, which we explored in this paper between touch transition, button transition, and automatic transition. There is a reality distinction method where we only used one version, which is the yellow-blue color coding. There is an environment filter where we filtered the virtual environment statically, but which could be expanded towards more smart, context-aware dynamic filters. There is an environment foundation, so we chose to take the AR user's perspective, but we could also design a blended space specifically for the VR user. And then finally, there's the scalability. So when more and more virtual content is introduced, it might cause more conflicts between the objects. And as such, you would need to introduce ways of solving this, such as transparency effects or slightly moving objects around to make them not collide with each other. In conclusion, we introduced a total of 5 different cross-reality transition techniques, especially the novel blended space concept where users see both environments simultaneously. And we, based on the idea of blended spaces and the study, we defined guidelines and discussed blended space design aspects. So thank you for your attention, and I look forward to answering your questions.